Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is pretty interesting because it's associated with research. And in this context, I shall discuss about the role of solvents in chemical reaction and with one MCQ. So you can see lots of solvent structure are provided here. So we shall learn, and this video is somehow research related, and I shall try to explain as easy as I can. So any criticism or suggestions are highly welcome. So before going to details, the MCQ. You can see image of a glassware here. So you have to say what is the name of this glassware. 4 options are provided. I request you student, please pause the video, try by yourself, and please write your answer in the comment box, and definitely at the end of this discussion you will have your right answer. Now let's come back to our main topic. What is actually a solution? The basic idea, because means a solvent ultimately can create a solution. So when one substance is dissolved into another, a solution is formed, and this is opposed to the situation when compounds are insoluble. Means if you mix sand and water and shake it, will they mix together? Obviously no. After some time they'll settle down. So in solution, all of the ingredients are uniformly distributed in a molecular level, and that's why no residue remains. You can see a single phase. If you do filtration, you'll have nothing because everything is in the liquid form. A solvent solute mixture consists of a single phase and all solute molecules occurring as solvents. So means solvent solute complex. As opposed and separate as continuous phase in suspension, this emulsion and other type of non-solution mixture. Now, the ability of one compound to be dissolved in another is known as solubility, and if this solubility occurs in all proportion, then it is called miscible. For example, ethanol. So this is, you can see ethanol, and this is water. Ethanol, water, miscible in all proportion. Acetone, water, miscible in all proportion. Okay, so that's why they are called miscible. Now, second point is the boiling point. Means at a particular temperature where the liquid solvent is converted into gas, means it evaporates. And actually this is an important property because it determines the speed of evaporation at particular temperature. For example, a boiling point of a solvent is 110 degrees centigrade, and you are giving a particular temperature. So from this boiling point data, you can guess what will be the evaporation pattern of that organic solvent. And some other factors also important here, like hydrogen bonding, etc. Now, the most interesting point is that the boiling point indicates up to which temperature the solvent could be safe to carry out a chemical reaction. For example, let's consider the temperature is 110 degrees. Let's consider it's a toluene type mixture. Now you can do any chemical reaction using this solvent up to 130 degrees centigrade under refluxing condition. Okay, so that much increase 20 degrees centigrade, it's okay for this toluene as solvent. Now if you want to carry out this reaction at 160 degrees centigrade, everything is same, solvent is same. Is it possible? It's risky, student. Why? Because at 160 degrees centigrade it will generate huge amount of vapor pressure, as the speed of evaporation is significantly high at this temperature. So under normal refluxing condition you can't do the reaction, but there is another setup known as sealed tube or high pressure tube. Using that setup you can do reaction at 160 degrees centigrade using toluene solvent. I shall discuss in some other lectures about it. So this boiling point indicates that up to what temperature you can carry out the reaction with safety. Now in this context, we can categorize solvent into 3 different categories: a low boiling solvent, medium boiling solvent, and high boiling solvent. For low boiling, BP below 100 degree. For medium, BP between 100 to 150 degree, and the high boiling is BP above 150 degree. For example, when we talk about DMSO or DMF, we say it's a high boiling solvent. Why? Because its boiling point is higher than 150. Now another interesting point of solvent is density. So if you compare this diethyl ether versus water, this diethyl ether is less dense, that's why it will remain on the top of this solvent, top of water layer. Not only that, if you take ethyl acetate, it's a very important solvent, student. So ethyl acetate, and if you take water and ethyl acetate, mix it and allow it to settle, then what you can expect? That this ethyl acetate will come or store in the above side, okay, and water will go to the below side, because ethyl acetate is lighter than water, okay. An important exception in this context are the most of halogenated solvent, because for example this dichloromethane or chloroform, it will sink to the bottom of the container, leaving water on the top layer. So you can see this is dichloromethane or DCM. Similar thing you can see for chloroform, water remains in the top. So when you are doing a workup, and what you are planning, actually you are washing the organic solvent with aqueous medium such that polar material should come out. Then in case of dichloromethane, you have to collect this bottom layer, and if you are using this ethyl acetate as a solvent during workup, then you have to collect to the top layer. So this much precaution you need to take while using those solvent. Now actually this is a crucial to remember, where partitioning compound between the solvents and water in a separatory funnel during organic synthesis. So this setup, glass setup, is called separatory funnel, and whenever we do a chemical reaction, generally, I repeat, generally, we first evaporate to dryness the solvent. For example, if it's some other solvent, and after that we use ethyl acetate water, DCM water, depending on the polarity, solubility of the molecule. Now in this context, you may know one risky issue or hazardous thing, that is epoxy explosive peroxide formation. And in this case, who are responsible to have such kind of peroxide formation? Actually ethers, because in presence of oxygen and light, these ethers like diethyl ether or tetrahydrofuran can form highly explosive organic peroxide upon exposure to oxygen and light. And that's why you see that ether or THF are kept in amber color bottle or brown color glass bottle, okay, such that light can't go inside it. And THF is more likely to form such peroxides than diethyl ether, because they are prone. And in this case, and the interesting property, one of the most susceptible solvent for this is diisopropyl ethers, but all ethers are considered to be potential as peroxide source. Now question why or how? If you look at this, actually this oxygen is a diradical, I shall come after some time, and what it does, it abstracts this proton. So if it abstracts this proton, then what it will do, it will produce a radical here. And if you look at this radical little carefully, two methyl groups are attached to this radical, because radical means you can consider sp2 hybridized carbon. And not only that, there is an oxygen atom with lone pair of electron. So these radical has maximum stabilization. That's why it is most susceptible for this peroxide formation. So this peroxide formation. Now the heteroatom oxygen stabilizes the formation of free radical, which is formed by the abstraction of hydrogen atom by another free radical. For example, in this context I am talking about triplet oxygen. And you can see the mechanism for THF peroxide formation. What happens? This neighboring carbon hydrogen bond react with this oxygen, and oxygen is diradical, so it can react like a radical, so it will produce this, and ultimately this part will produce radical and another part will be hydroperoxide radical. Now in the next step, these two radical combines together, and student, remember, this is actually fish hook arrow. So this is fish hook arrow, it signifies the movement of single electron. So in this way, this covalent bond or single bond will be prepared, and ultimately if you look at what is this is actually a peroxo compound. So this is THF peroxo derivative. Now we are talking here about triplet oxygen, which is diradical in character. What about the singlet oxygen? Actually singlet oxygen are far more reactive, student. I've already discussed dedicated lecture on this topic, so you may visit for better understanding. Not only this, for example, this benzaldehyde PHCHO, it's actually a liquid compound, but after some use, when you open the benzaldehyde bottle, you see some white, means some crystal solid are there on the neck of this bottle, or means this storage bottle. Question: why? Because in presence of this triplet oxygen or atmospheric oxygen, what it does, this benzaldehyde converted into benzoic acid, and this benzoic acid is solid compound and it stores as a crystal there. So that mechanism is also similar type of mechanism like oxidation using triplet oxygen to produce the peroxide derivative, and later on ultimately it is a overall oxidation process. Now, the another most important question: why do we use solvent in chemical reaction? First of all, we need to bring all the reactants in the same phase, and if they come same phase, they can interact properly with proper conformational orientation. What do I mean by the statement? For example, two reactants are in same phase, then they can come closer, and after this they can collide in proper conformational orientation, I mean both energy and symmetry wise, such that a particular bond making or particular bond breaking possible. And chemistry is nothing but bond making, bond breaking process. Now, so not only that, solvent can participate in chemical reactions too. For example, DMSO and DMF, they can participate in nucleophilic or SN2 substitution by easily solvating cation, because cation is deficiency of electron Mn plus, and what this DMSO DMF does, they coordinate to the this metal and stabilize them. Consequently, the anion became free or naked. Consequently, its reactivity increases. Now, solvent helps to provide the energy or heat to the reactant such that chemical transformation became possible. How? For example, you need to carry out a reaction 100 degrees centigrade, and you are using a particular solvent, for example toluene, as a solvent whose boiling point is 110 degrees centigrade close to. So in this case, using this solvent, you can heat at the bottom, and this solvent will transfer this energy, thermal energy, to the molecules which are planning to react together. Now, solvents helps in purification of the compound, like column chromatographic separation, workup, just some time before I have shown. So they are also used in purification of the compound, because solvent have a particular solubility, and that solubility can change compound to compound. So obviously solution and other solution related property could also change. But remember student, toxicity of and hazard of organic solvent should be considered while using this. So that thing I shall come after some time in details. Now, after learning all these things, a simple question comes in our mind, that which solvent is good or less toxic or easy to handle? Obviously the answer is water, because water is the least toxic solvent. However, majority of organic compounds are actually non-polar in nature, and that's why they are not soluble in water. So although water is a benign solvent, but because of this property they are not used that much extent. But by the way, there is a concept that is PTC, or phase transfer catalyst. So using this concept, what we can achieve, we can take some part of the solvent as water, some other organic solvent, and this PTC is unique such that it can allow the reactant to react together. And by the way, I have already make a dedicated lecture on this PTC, you may visit for better understanding. Now, some chemicals are very reactive to water also. For example, like organometallic compound, because water has a polar hydrogen oxygen bond. So if the reagent, for example organolithium, is itself a very polar carbon ion type, so it reacts with this polar proton, and ultimately what it produces? It produces this alkane. So in this way reagent could be destroyed. So that's thing also we must keep it in mind, and for that purpose we should use anhydrous solvent. And in this case, water miscibility issue with other organic solvent is another problem too, because if you look at this chart, this is water and this is water. These blue dots are immiscible. Okay, so you can see water is immiscible to majority of solvent. So that is the issue. So question comes that, okay fine, water is not a good chance, although it is the best, but it can't show the property. Any alternate? Yes student, alcohols. or more specifically if I say ethanol, because alcohol has this OH group, so it's polar, so it's capable to dissolve polar moiety. Not only that, alcohol has this organic part, so this organic part is responsible for the solubilization of organic groups. And further, this alcohol, actually bioethanol, could also be prepared from renewable sources like this corn, sugar, etc. And how they are produced? They are produced by photosynthesis, means they are produced by CO2 fixation. Consequently, the overall carbon footprint of the process is relatively low. And not only that, water is relatively less toxic too. Now, sometimes some people blame that alcohol is bad. My family member, my husband, my wife drank alcohol and destroyed life. Alcohol is bad. Actually, student, alcohol is not bad. The habit of overconsumption of alcohol is bad. You can't digest alcohol, it's your problem, but you can't blame the solvent, because alcohol, it's a very good solvent. Not only solvent, it's a very good fuel too. And in future, the countries are planning to replace this fossil fuel with some renewable fuels, and alcohol is one of the potential sources. So please don't blame alcohol. Focus on your habit and intention first. Now, so that's a funny thing. Now let's come to the solvents for organometallic chemistry. Sometime before I told that water or this polar protic solvent having this OH group could not be used in organometallic chemistry, because this delta positive proton will react with this organometallic complex and destroy them. And so for organometallic chemistry or catalysis, where organometallic catalyst are uses, anhydrous solvents are essential, which anhydrous means non-hydrous, means water is absent. And in this case, the THF or dioxane are one of the best option. Why? Because if you look at this solvent, this THF or dioxane both have lone pair of oxygen, and these lone pairs of oxygen could be donated to the metal center, or organometallic compound could be stabilized in this way. For example, if you check Grignard reagent, which is RMgX, so this magnesium is having 4 electron in the outermost valence shell. So that's why what it does, it prefers to coordinates with 2 THF or 1 dioxane, because dioxane is a bidentate, 2 oxygens are there. So it coordinates and ultimately it fills up its octet in this way. So that's why these solvents are important in organometallic chemistry. Now both solvent means this one for dioxane and THF both could be prepared from bio-based sources, like this 1,4-dioxane could be prepared from ethylene glycol, and this THF could be prepared from pentose sugar via furan as intermediate. So that is another interesting property, because right now every country is planning to shift their value chain chemical production, means this value added chemical production, from petroleum based sources to non-fossil fuel based sources. And for in that context, such kind of solvents are better, because they could be prepared from biosources too. And this solvent could easily be dried by sodium benzophenone reflux under inert condition, because sodium reacts with moisture and produces hydrogen, and benzophenone creates a blue color. So in this way it could be detected that okay, under this condition, anhydrous condition, means under this reaction setup, anhydrous condition is maintained. By the way, I shall discuss a dedicated lecture on this topic in future. I guess it will help you more. Now let's come to that point, that is high boiling solvent. For example, here dimethyl sulfoxide, which is also called as DMSO. The BP, boiling point of dimethyl sulfoxide, is 89 degrees centigrade. It's pretty high, more than 150, means 150 degrees centigrade. Not only that, this dimethyl formamide, which also has BP 150 degrees centigrade, that is greater than 150 degrees centigrade. So that's why they are called high boiling solvent. Not only that, they are highly polar. Why? Because this DMSO can have another canonical form. You can draw it here. So this is S, this is O minus, this is S plus. Although such kind of canonical form having charge separation has less contribution into the overall electronic distribution, but it has some impact. Not only this, in case of DMF, the lone pair of nitrogen could be pushed here and it could be open. So the canonical form should look like this is O minus double bond N this. So because of this canonical form also, this DMF is a very polar solvent. Now it is a very polar solvent, it's an organic solvent, it dissolves many reagents, so that's a good thing. But if you do any reaction using DMSO or DMF solvent, it creates an additional problem during the workup or removal of this solvent by workup, because generally what we do, we use rotary evaporator and it can, I guess, remove this DMF, but it can't remove DMSO efficiently. So that's a big problem, how to remove this DMSO. Not only that, if you give higher temperature for this evaporation of the solvent, then there is a chance that your compound may degrade, which is in the reaction medium. So for that purpose, what we need first this DMSO containing reagent. First, this DMSO use should be minimum, and second, inside this container having this solution having DMSO, 5 to 10 times water needed or added, and allow it to start. Then what happens, this water get mixable with this DMSO and this DMSO comes out in the water medium. Then for example, this ethyl acetate water workup, ultimately this ethyl acetate extract the organic compound and the polar compound goes to the water layer. Now in this case also, as I told, this DMSO and DMF can also stabilize the intermediate such that the rate of SN2 type reaction or reactivity of nucleophile could be increased. Now, so alternate of this DMSO D6 or DMSO and DMF is PTC. Why? Because PTC is actually a polar molecule. Not only that, it is soluble in both organic as well as aqueous medium, and it is actually kind of a salt. So because of this salt, means this distinct cation and anion, it is soluble in polar solvent. Now not only that, it has 4 big alkyl group. Right now here I have taken tetrabutyl, but other long chain compound are also possible, and that's why they are soluble in both organic as well as inorganic medium. And that's the thing. And another interesting issue is that it is soluble in majority of solvent. And not only that, right now because of green chemistry, we are planning to increase the use of water, but we want to reduce the use of organic solvent. So for that purpose, this PTC is one of the best option. Now next is the anhydrous solvent. This anhydrous solvent or dry solvent, sometime we purchase or we produce this anhydrous solvent, and these such solvents are needed when we are planning or performing any moisture sensitive reaction, or some people call it as a dry reaction, anhydrous condition reaction, because the moisture content of majority of organic solvents are significantly low, but it's actually have significant impact. For example, you are doing a 2 millimole reaction in 100 ml solvent, and in 100 ml means huge amount of solvent, although the water is in very less or low concentration, but with respect to 100 ml its amount or number is significantly high that it can destroy that reaction. For example, if you want to prepare a tertiary alcohol from this acetone and RMGX in THF, so if you take anhydrous THF, that's fine, but if you don't take anhydrous THF, that inside the THF there is water, and we know water is more polar, and these Grignard have some carbanion character, and what it does, it acts as a base and abstract this proton. So this is actually an acid base type of reaction, and we know that acid base reactions are fastest reaction. So that's how these RMGX will unnecessarily destroyed. So for that purpose, it is always advisable to take moisture free chemical environment, including moisture free solvent or dry solvent. Okay, and in this context, 2 types of method commonly could be used. One is physical drying method by using molecular sieves type material, which is actually zeolite, and some chemical separation of water from the solution is by using, for example, metallic sodium, calcium hydride, etc. For example, if you want to dry THF, this metallic sodium is enough, but if you want to dry this DCM, because CH2Cl2, then this calcium hydride could be utilized, because if you put sodium and you allow to dry this DCM, what will happen? The electron coming from sodium will reduce the carbon chlorine bond, so that side reaction will occur. So that in order to avoid that, some purification, or you can say moisture removal technique are different for chemical to chemical. Now, in this context, another is solvent for workup of a chemical reaction, and in this context proper selection of solvents are essential. Why? Because solvent must be water insoluble, then only the phase separation will be observed in this mixture bottle separation. Okay, and in this case that layer separation will happen. Now, polarity of the solvent could be selected such a way that only product come in that organic solvent, not the reactant or byproduct. For example, you are producing carbene from this imidazolium salt. This is actually a imidazolium salt, and these salts are very much polar, and if you allow this to react with a very strong base, it will produce carbene. Carbenes are, student, neutral, so less polar. So what you can expect? So in this case carbene is less polar, so it can come out in solvent like toluene. So if you, after the reaction is done, if you allow the reaction mixture to evaporate to dryness and then you add this anhydrous toluene, then what will happen? Carbene will come into the toluene mixture, although other things will remain there, because toluene is less polar. Toluene is selectively solubilizing this carbene because of its low polarity. So that's a very smart choice. So whenever you do any workup, your choice should be smart. For example, a particular compound is soluble in both ethyl acetate and DCM. In DCM, then question is what solvent you will use for workup of this reaction. I suggest you to use ethyl acetate because DCM is more polar and there is a chance that some byproduct may come in DCM too. So for that purpose, ethyl acetate is a first choice. Now, not only that, if a reaction mixture contain water miscible solvents like THF or alcohol, it is advised to evaporate the solvent first. Otherwise, this alcohol will soluble in both water as well as this organic solvent, so no clear phase separation will be observed inside the separatory funnel. That's a problem. Now, not only that, if DMS for a DMS or DMF reaction, aqueous workup is essential to remove the solvent, and above everything else, for further purification after this separation, means phase separation, crystallization, precipitation or column chromatography should be performed to make it more pure. And in this context, crystallization is the best because crystallization ultimately results the maximum purity, but it's a slow process. Now, since you are talking about solvent so much, then another point, that is toxicity and environmental hazard, should always be an important issue, because proper precaution is essential while handling this organic solvent, because they are toxic not only for human, they are toxic for the environment too. So human or this environment should not come in direct contact with this organic solvent. In this context, one of the most hazardous is this halogenated solvent, for example DCM, which has a CCl bond, and such kind of carbon chlorine bonds are dangerous because they can be a potential carcinogenic material. So that's why whenever we are doing reaction with such kind of solvent, DCM, this chloroform, those things, we should not throw such kind of solvent into the you may consider this drain or in normal laboratory etc., because it will have a negative effect on us. And because of this, I guess you have observed in your lab there are two waste jars, one is halogenated and another is non-halogenated. So that's why halogenated solvents are given extra focus for their bad property, I believe, means this carcinogenic property. Now, we should try to recycle solvent as much as possible, like we should recycle acetone, alcohol, which we use to remove the residual water after the cleaning. So in my laboratory, what we do, we first clean a particular glass jar, for example round bottom flux, with soap, water or detergent. After this detergent cleaning, we used to clean with water, means remove the excess detergent. Now after that, we add this acetone inside that RB, and we try to take the water present inside the RB, because acetone and water is miscible in all proportion, and after that we keep this inside this hot air oven to make it dry. But in this context, what we are actually using, we are using acetone, and we stored this acetone in some separate jar, and later on we evaporate this acetone inside a rotary evaporator and collect this acetone, because water boiling point is 100 degree, acetone I guess close to 60 degree. So what happens, so I forgot the exact boiling point. So what happens, that low temperature acetone comes out but water doesn't, and in this way we get the acetone again and we use this acetone for the same purpose. So this is actually recycling. I heard that some lab also uses alcohol as their washing solvent, and they can do the same thing with alcohol too, because every solvent has some negative effect for environment. So we must reuse as much as we can. Now, in conclusion, what you have learned today, that solvents are essential for any chemical reaction, but we should use them carefully to reduce the chemical pollution, that is carcinogenic nature. And by the way, there are some reactions, for example solid state reaction, they don't need solvent, but for simple organic reaction solvent is essential. Now, solvents after chemical reaction should be processed carefully such that no hazardous material should come out in contact in both human and environment. For example, if you throw some amount of this halogenated solvent inside your sink, then what will happen, that solvent will flow through the sink, means the drain, it will come and it will ultimately mix to the local bodies or water bodies, then it will affect the aquatic life, for example fish, and when we eat this fish it will affect us also. So that's not a good thing, okay? And we should always try to find safe alternative first. For example, for a particular reaction you can take benzene or toluene, any one you can take. So what will you choose? Obviously you should choose toluene, because this toluene in our body could be oxidized by enzymes. If it goes inside the body through inhalation or some other effect, it will be oxidized by our enzymes, and ultimately it will produce the benzoic acid derivative, and ultimately it will come out from the system. But if you use benzene and it goes inside the body, will it come out that much easily? Obviously no. It will create the toxic, it will impact the toxic effect of this molecule. Not only that, if you check ethanol versus methanol, so what happens, and if it goes inside your body some amount, what will be the consequence? This ethanol is converted into acetaldehyde, which is not that much toxic, but it's responsible for the hangover of alcohol. But if you use methanol, it will be oxidized and produce formaldehyde. Student, it's pretty toxic. That's why it is better to avoid methanol for laboratory use. Instead of that, we can use ethanol. It's a better alternate. Okay, so let's come back to the MCQ. What is the name of this glassware? Name of this glassware, you can see this is called Schlenk flux. And then what about this RB in Erlenmeyer and conical flux? Actually this RB, round bottom flux, is this one. Okay, and by the way student, both Erlenmeyer flux and conical flux both is this same, have two names. So this is the end of this discussion. I believe this video may be useful. I thank you for watching. If you consider my content to be worthy, please help this channel to grow, and if possible please visit my another channel where I upload global warming and climate change related videos. So stay happy, stay blessed. See you in my next video. Bye bye.